Kia ora Year 12 and Year 11. Here's a quick video doing a complex numbers proof from the paper 32, summer 2014. So this is a really nice question that is fine as long as you keep an eye on where you're going. And if you don't, you can get kind of mucked up. So we've given a complex number w, and it's got modulus 1 and argument 2 theta radians. And we have to show that this is equal to I tan theta. So when you're doing this question, I want you to keep your eye, on I tan theta the whole way through. So first of all, let's work out how we can write w. Well, we're given that it's got modulus 1 and arg 2 theta. So clearly the place to start is to write that in polar form. So w is equal to cis 2 theta. Now you could do this question using exponential form, but I'm not going to do that. When I looked at it, I went straight to polar form and worked my way through. So you know we're going to end up doing basically a trig identities thing with this. So on the left-hand side, we've got w minus 1 over w plus 1. So let's just write that out first. Cis 2 theta minus 1 over cis 2 theta plus 1. Now we want to group the real and the imaginary parts of that. So we're going to write that out as follows. We're going to have cos 2 theta minus 1 plus I sine 2 theta over cos 2 theta plus 1 plus I sine 2 theta. Now remember I said we've got to think about where we're going the whole time. We want to end up with I tan theta. And it's always a good idea to do that in proof questions. But in this one, if you don't do that, you are going to go wrong, I think. So what do I do now? Well, my brain sees the following things straight away. Cos 2 theta minus 1 here and cos 2 theta plus 1 here. And probably I want to get rid of those minus 1s and plus 1s. So I'm going to choose the right form of the double angle identity to do that. In the top line, also known as the numerator, I'm going to replace cos 2 theta with 1 minus 2 sine squared theta because I've got this 1 and this takeaway 1. I'll leave that as it is for now. And then in the bottom line, I'm going to use the other double angle, cos 2 cos squared theta minus 1 plus 1 plus I sine 2 theta. Right, what does that give me? Well, I've got negative 2 sine squared theta plus I sine 2 theta. Now it's time to work on this double angle. It's going to be 2 sine theta cos theta I. And here we've got 2 cos squared theta plus 2 sine theta cos theta I. Right, so this is just the only possible replacement for sine 2 theta is 2 sine cos. Now, we've got a lot of 2's in there, so let's get rid of those. So divide everything through by 2, and then let's see whether we're getting somewhere. And here we've got cos squared theta plus sine theta cos theta I. Now, remember, we've got to look at how we want to get out I tan theta. So let's start seeing if we can get something coming out as a common factor. And yep, I can see a common factor in the numerator. I've got a sine here and a sine here. That's good because we know tan is sine over cos. We've got a cos here and a cos here. So take out these common factors and see what to do next. Now, we're actually nearly there, but I think it's quite easy to miss the next step. Right, I can see a tan theta, that's fine, but I can't see an I. So let's see what's going on. We'll write the tan theta. How can I write this to get a common factor of I? Well, here, I've got an I here. I haven't got an I here. Let's write this and spot that that negative 1 is I squared. So I've got I squared sine theta plus I cos theta. And then here I've got I sine theta plus cos theta. Now finally I can see where I'm going. I've got an I here, I squared here and an I here. So we've got tan theta times I into I sine theta plus cos theta, which is the same thing as I've got in the denominator. So there we go. Right, so we end up with I tan theta as required. Right, but I'm just curious about whether you spotted that you had to find a way to factor out an I here, and that we've got this negative sign that looks kind of innocuous but can be usefully replaced with I squared. So let me know if you found that question fine, or if you had to really think about it and got stuck on it. Just leave me a comment or send me an email. Thanks for watching.